All right, so let's start with our bell work for today. So I have for you guys to solve for this equation here, and you have to find what x is. And if you take a look at this equation, this is what we call a quadratic equation because there is an x squared in it. Anything where x is to the second power is what we call a quadratic equation because it creates a parabola, if you remember that U shape. But just what we're doing here is trying to figure out what x here is. So to solve for quadratic equations, we can use factoring, and we can also use the quadratic formula to solve. So we're going to first solve this one by factoring. So if I was looking at this side of the equation, what I have to do to figure out how to factor is what number multiplies to give me 15. Two numbers that multiply to give me 15, but also add to give me -2. Remember, this was one of the tips that we do to figure out what our factors for an equation is. And this is where we write those two sets of parentheses. So I'm going to drop down that equal sign on the right-hand side, and we need two x's because we have an x squared. So x times x, when we FOIL, gives you x squared. Now, if you guys have thought about it, to get 15, maybe 5 times 3 will be our factors. So let's try that out. I'm going to set them down. What we have to do next is figure out what the sign is. Well, because this is a negative sign, that means one of these is a negative. So if I have the middle term being a -2, so if it's a negative number, that means that the bigger number is the negative sign. So basically, whatever the middle term is, whatever that sign is, the bigger number gets that sign. So in this case, this middle number is a negative. The 5 here, the bigger number is a negative. So then the 3 is a positive. So what do we do once we get our factors? Well, this is the easy part. You just have to set your factors equal to 0. And now just solve for x. So in this case, I have to add 5 to both sides. 5's cancel. X is equal to 5. And then this side here, I would have to subtract 3. And so x is equal to -3. But, and then this is it. We found our two x values for this quadratic equation. Remember, if the degree is 2, that means we have two solutions. That's why we see two x's here. All right. So what if you can't figure out the factors that multiply to give you the 15 and add to give you the middle number? So if you're struggling with your factoring skills, or you're struggling to figure out what two numbers multiply to give you that number, sometimes you can't factor. So as a backup plan, we learn the quadratic formula because the quadratic formula will take care of any case and solve for a quadratic equation. So if you remember the quadratic formula, that's x equals -b plus or minus the square root b squared minus 4ac all over 2a. Or if you know Pop Goes the Weasel, it basically goes like this. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. So that's one way you can remember the quadratic formula, is to sing Pop Goes the Weasel. Okay. So enough with songs here. To use this formula here, you need to know what A, B, and C is. Okay, so if you remember, quadratic formulas have to be written in standard form before you can solve for them. Like this one here is in standard form, and so is this one. So what I mean by standard form is this format. Ax squared plus bx plus c equals 0. Basically, one side is 0 where all the other parts of the equation are pushed to one side, the other side. And when you have it in standard form, you want to make sure that the exponents are in order. So like x squared, x to the first, and then your constant. So from here, if I want to know what, let's say, my a is, and my b and my c, my a here is next to the x squared. So the coefficient in front of x squared is 1. So a is 1. B here is a -2. Make sure you drop that sign with it, 2. So that's a -2, and C is -15, our constant. Now all we got to do is plug these numbers back in for the quadratic equation. So let's set that up here. So x is equal to negative, don't forget that negative that's already with the b, so that gets brought down. But b is -2, so now I'm going to plug in -2 plus or minus the square root. B squared is -2 being squared. So let's write that in. -2 squared minus 4ac. A is 1, c is -15. All over 2 times a is just 1. So I've plugged everything in, now we just got to simplify. So let's start from the top here. Top here, 2 negatives, so that makes a +2. Plus or minus the square root, there's a -2 being squared. So -2 times -2 gives you +4. So that's 4 now. Now, this chunk here, what I like to do is look at the signs. There's a negative here and a negative on the 15. If you multiply these two, you make a positive. So I already know my sign is a positive. Then I take my numbers and then I actually multiply. So 4 times 1, 4. 4 times 15, 60. Over 2 times 1, well, that's just 2. And so if I clean this up just a bit more, like in that square root there, 4 plus 60 gives you 64 over 2. So square root of 64 is a very nice square root. It is 8 over 2. And so now from here, I just need to clean up this a bit. So what we do at this point, once you have simplified the root, is split it up into 2 equations because you got a plus and a minus sign. So you have x equals, 2 plus 8 over 2. And you have x equals 2 minus 8 over 2. So now we got to actually simplify this a little more. So 2 plus 8 gives me 10. 10 divided by 2 gives me x equals 5. Whoa, and that's the same answer that I got before, right? This here is the same number that I got over there. And so now let's take a look at the other one here. So we have x equals -2 minus 8, which is -6, divided by 2. And so that's going to be, let's see if I can crunch this. There we go. X equals -3. And so there we have it. We got the same 2 answers as last time, and we should because we're solving basically the same equation, but different styles. So just as a summary here, factoring, if you are very good at your multiplication tables, I highly recommend to do factoring first because notice we were able to find the solutions very quickly, fewer steps. But if you're not good at the multiplication table, I would just go straight to the quadratic formula and use that instead. Because it's really just a matter of knowing what your A, B, and C is and plugging into the formula, and then you're just doing the simplifying. There's more steps, but less thought process of figuring out what multiplies to give you this number and adds to give you this number. Do you see what I mean? Like, you could just plug it in and get your output automatically, whereas this one you have to be a little bit more thoughtful. But it's good to know both of them. All right, so now let's go back to solving logs. So yesterday, or the lesson before this, we learned about expanding and condensing logs using those 3 properties. So I'm going to write those 3 properties above here. Don't feel like you need to because you have those in your journal if you took the last notes. So the first one we learned is when you have x and y being multiplied inside, when you have 2 things being multiplied inside of logs, you can separate them using addition. So you can separate the 2 things inside the parentheses using addition. Let me actually fully write that out. And then 2, we learned about a log. When you have division, you can separate it using subtraction. And then last but not least, we also learned about exponent rules for logs. If you have an exponent on the base of the inside of the log, sorry, not the base, but like, let's say this x here has an exponent, then that exponent actually can be expanded by putting the exponent on the outside here. So now I can have n where the exponent's in the front, and x is just left behind inside. So that's how you expand a exponent. So now let's take a look at some of these notes here. So we're going to be talking about solving for logs, and sometimes there are multiple logs in an equation, as you can see with these problems. There's lots of logs going on. So how do you solve a problem that has multiple logs? Well, we basically use the idea of condensing the logs. So we condense the logs into one log to make it easier for us to solve. Because once we condense it into one log, basically we go back to solving it the way we are used to. So that could be like using the heart method to change it to an exponent. So you'll see what I mean here once we do some of these problems. But one thing I do want us to make aware of, that you must check your answer when you are working with solving for logs, because logs can't have zeros and negative numbers inside the log. So just be aware of that. Once you get your answer, you've got to check and plug it into the log if it has an x, and see if you get a negative or a zero number, because if you do, that solution is invalid. So let's start out with part A here. There are two logs here, and I can combine them or condense them by using multiplication, right? Because there is a plus sign in between. So one of the rules is, well, if the logs are added together, then you can join them using multiplication. So that's exactly what I'm going to do here. I'm going to try to combine the things inside the logs by using multiplication. Now this log here is a base of 10, right? Because there's not a base written. So if I join these two, x times 4 is just 4x. So I'm just going to write it this way. Equals 2. And so if you look at this problem, this problem, if I were to try to solve for x, looks very similar to what we did a few days ago. So if you remember like page 2 of the packet 11, this is when we're trying to get the x by itself. So we change this log to an exponential to help us solve. So you can use the heart method here to help you do that. So I'm going to go ahead and do that. So I have, starting from my base, going to my 2, and then going to my 4x. So this is 10 squared equals 4x. And then I just need to simplify. Notice that the x is now on this side. So let's see here. 10 squared is going to be 100 equals 4x. If I divide the 4 over, that cancels, but then I have to divide that one over. And so x is equal to 100 divided by 4 is 25. But hold up, we need to check if this answer is valid. So if I take 25 and I plug it in for this x, it's still going to be log of 25, which is a positive number. So it's not a 0, it's not a negative. So as long as when you plug it in, it's a positive number, you're good to go. It's good. So I'm going to put a check mark here to say that I have checked it and it's a valid answer. Okay, so next one here, I have these two logs are joined together by subtraction. So if I go back to my properties here, subtraction means that I can combine them using division. So I am going to join them together. Now this one also has a log base 10, so I'm going to explicitly write that in. Now, the other lesson from last time when we were condensing and expanding, you might have heard me say that it didn't really matter what the base was. As long as I'm carrying it through, it's fine. If a log is not written, I don't have to write it. And that's totally fine when you're just condensing and expanding. But this time around, we're solving. So we need to know what that base is, or else you're not going to be able to find your answer, right? So now I'm going to bring down that 1. Okay. Looking at this here, I have a 10 as my base. I'm going to start with my base to my 1 to my fraction. Okay. Let's see what we get here. We get 10 to the first power equals 3 over x. Now, 10 to the first power is just 10. So the left-hand side, not much I can do here. This side here is kind of freaky, right? You got this 3 over x And we're not used to seeing x being in the denominator. So how do I get x out of the denominator? Because I want to get x by itself. Well, this x here, even though it's in the denominator, we can also assume that's dividing, right? Things that are in the denominator is like dividing this 3 by x. So to undo division, we can use multiplication. So I'm going to multiply this side by x because that crosses it out or cancels it. But if I do that on the right-hand side, that means I have to multiply this side by x. Okay, no worries. It looks like this side is now 3, and then 10 times x is 10x. Oh, would you look at that? Now this looks normal to me. And so now I have to get this 10 out of the way, so I'm going to divide by 10. And that cancels, and x is equal to 3 over 10. And you can write that as a decimal, but I think I'm okay with a fraction. Now, if I were to plug this in, this is a positive fraction here, so if I plug it in for this x, I'm good, because it's positive. No negatives or zeros here. So I'm going to put a check mark for that answer. C is next. So let's take a look at C here. C is also joined with a plus sign on these two logs. So I can condense this using multiplication. So let's go ahead and do that. This one is also a log base 10. Lots of log base 10s here. I don't know what Miss Shane was thinking when she made these problems. She probably just forgot to put a base. That sounds like me. Anyhow, so I've condensed the two logs here by multiplication. And notice that both sides here have a log base 10, right? So if both sides have the same base, we learn that they cancel. Boop, boop. So that means that the inside of the parentheses in the logs drop down with the equal sign. So 7x equals 28. And now I just have to solve for x. So divide by 7 on both sides. That cancels. And x is equal to 28 divided by 7, 4. And you got to check my answer. So plug this 4 back in for this x. It's a positive number. It's good. So I'll put a little check mark there. And that's it. So the big part about solving logs is that if you have multiple logs here, you can condense them because that allows you to deal with just one log. And then you can use the heart method to try to solve for your x. Okay. Let's take a look at a few more examples. Example number 2. If I look at these two here, I have a plus sign in between. So like before, I'm going to join them using multiplication. All right, so let's see what we got to do here. I have log base 2 x times x minus 6 equals 4. This problem seems very similar to yesterday's problem where because we had x and then a parentheses to multiply, we have to distribute that x. So I'm going to go ahead and do that. So I have log 2 x squared, because x times x gives you x squared. X times negative 6 gives you negative 6x. And then this side is a 4. All right, now the log is, I just have one log here, and it's by itself. So I can use the heart method to change it to an exponent. So I'm going to go ahead and do that. So we have 2 to the 4 equals x squared minus 6x. And so 2 to the 4th power is like 2 times itself 4 times, that's 16. X squared minus 6x. And then I just need to, well, oh wait, hang on a minute. This equation here has an x squared in it. So this is a quadratic. So now we got to think about like the bell work there. So if we have a quadratic, that means we have to either factor or use the quadratic formula. But first thing, let's try to get this in standard form. In other words, one side needs to be 0. Now, it's a lot easier to move this 16 over to the other side than to move these two components to the other side, okay? So if I want to move this 16 over, I just have to subtract by 16. So subtract by 16, boom, that cancels. So now this side here is a 0, and then I have x squared minus 6x minus 16. And so now I'm going to try to maybe factor first. Let's see if this is factorable. So 1 multiplies to give me 16 and adds to give me negative 6. So let's think. 8 times 2 can give me 16. Let's see. If I set my two factors down, so I'm going to set my parentheses and my x's. If I drop an 8 down and a 2, if I want a negative 6, that means that the big number needs to be a negative and the small number needs to be a positive. Let's see if that works. Negative 8 plus positive 2 does give me negative 6. So this is looks like the right factors. Now I'm going to set the factors equal to 0 and solve for x. So if I add 8 to both sides, x is equal to 8. Boom, that's one of my answers. Subtract by 2 on this side, x is equal to negative 2. And that's my other answer. But hold up, are they valid? Are they both valid? So let's check. 8, plug it into the original equation. 8 in this log of x is just a positive number. This side's okay. But here's an x on this log. So 8 plug in here. 8 minus 6 gives you positive 2. So this 8 is fine. Let's check the negative 2. Negative 2, put it in for this x. Oh, no. Negative 2 and for this x is a log base 2 negative 2. That's a negative log inside. So in this case, this is not a valid answer because when we plugged it in, we got a negative value inside of log, and that's a no-no. All right, so you can see here that that's why we need to check our answer, because sometimes one of them or all of them are not the right answers, and we need to know if our answers are valid or not. Okay. Let's take a look at B here. So for B, if I want to condense these two together, because I got two logs, there's a plus sign, I have to multiply. So log base 3, 2x times 5. Well, let me actually write that out. 2x times 5. Bring down this log. Then I can simplify this log. Feel free to skip that mini step that I'm doing. I'm just showing all the steps. So I've multiplied 2x with 5x, and I got 10x on the inside. And so what I notice is that both sides have a base of 3 for their logs. And so in this case, they cancel. Boop, boop. And now I just have a 10x equals 50. Well, then I just have to get x by itself, divide by 10, divide by 10. X is equal to 50 divided by 10, which is 5. All right, so check my answer. Plug this 5 in for just this x, I guess. So 2 times 5 is 10. So totally okay because it's positive. So check. All right, let's do another example, but let's take a look at natural logs, because we learned yesterday that natural logs are use the same properties as logs because natural logs are basically a special type of log. So here I have a natural log problem, and we are going to solve this in 2 different ways. So the first way we're going to solve it is by how we have been thinking of it, how we've been doing it, which is the idea that we condense. So method 1 is trying to condense. And method 2, well, we'll talk about it later. So if I take this problem here and I try to condense them, like this side there's 2 ln's. So if I have a minus sign in between them, I can condense them using division. So that's what I'm going to do. ln 6 minus 2x divided by 3x minus 8. I divide this ln stuff with this ln stuff. And that equals 0. And so this goes back to the idea, okay, all the x's are inside. I got to get them out. How do I get rid of this ln that's in my way? Well, to get rid of ln, the inverse of ln is ease. And we learn to get rid of ln, we e it, or we exponentiate it. And that cancels out the ln. And then let's see. This side here drops down that fraction. But the other side here, let's try to simplify that. This is e to the 0 power. Anything to the 0 power is just 1, right? And so now when we look at this here, it's like, oh, geez, I got an x in the top and the bottom. How am I going to deal with that? Well, one way we can do this, and you saw this in one of the examples today, is that we can try to get rid of this denominator here, right? Because this is 3x minus 8 dividing the top. So if you want to get rid of division, you use multiplication. So I can multiply both sides by 3x minus 8. So because that will cancel out that side. But I have to multiply this side by 3x minus 8. Because anything you do to one side, you got to do it to the other. So the 3x minus 8 canceled on the left-hand side, dropping down at 6 minus 2x. And the other side, well, 1 times this, or 1 times anything. It's just itself. So that's going to be 3x minus 8. If that wasn't a 1 and that was like a 2, you would have to distribute the 2 to both components, or both terms. Just as a heads up. Okay, from here, this looks awfully familiar, right? We can try to get x by itself by moving stuff over to each side. So perhaps I'm going to move this 2x to this side by adding 2x. So add 2x, that cancels, drops down a 6. 3x plus 2x is a 5x minus 8. I got to add 8 to this side, that cancels. So I have 5x equals, let's think, 8 plus 8 plus 6 gives me 14. Divide that by 5. That cancels. So I've ran out of room. Let me write it over here. X equals 14 over 5. And voila, I have found x. So another thing you would do is to check your answer, but I'm not gonna go check my answer. I'm gonna save you some time here because I want us to get to more important stuff here. So I'm gonna just check it for you, and this one does work out. Okay, so method 2. The first method was quite lengthy, right? So here's a really nice way you can solve this problem too if one side is 0. So if you have 0 on one side, so how can I say this method? 0 on one side. I'll just keep it real simple and real direct. So if you have a 0 on one side, basically what you can do with this problem, I'm just going to rewrite the problem here, is you can move one of the ln's, particularly probably this one here because there's a minus sign. So because there's a minus sign here, I can add both sides with this ln, and that would cancel, and then that would go to the other side. So here's what I mean. So if I add ln 3x minus 8, this will cancel, but anything I do to one side, I got to do it to the other. So I have to add 3x minus 8 on this side. And so I have ln of 6 minus 2x left on this side. And this side here, 0 plus ln of 3x is just itself. And now I have ln's on both sides, right? So if I were to try to get rid of this ln, because the x is inside and I want to get rid of this l that's in my way, or sorry, ln that's in my way, I have to e it. But if I e this side, I gotta e that side, which is fabulous because they cancel out both ln's, right? Right. And so now I'm just left with 6 minus 2x equals 3x minus 8, which looks really familiar to what we did a moment ago, right? Because that's this step right here. Let me grab a red pen. That's right here. That's the step that we did a moment ago. They're the same step. And so then I would do the same process of getting the answer, but just get to the answer 14 over 5 for x. So I'm not going to show that part because that's the exact same stuff that we did here. But yeah, one way you can solve for problems when you have like a 0 on one side is just to move that to the other side if you notice that they're both ln's, or if they're both logs, or if they're both exponentials with the same base. Okay, so as a freebie to you, I am going to do packet 11. I believe this is on page 4, problem number 3, because that one's kind of a tough one. So I want to do that problem with you guys. So if you take out your packet, follow this problem with me. Okay, so I'm looking at number 3 on page 4 of the packet. This problem here has 2 logs, and they're joined together by a minus sign, so I know I have to condense this using division. So let's go ahead and set that up and condense it. So I have x squared minus 4 over x plus 2 equals log base 4, 1. And we learned that if the log's bases are the same on both sides, then they cancel, okay? And we can only, I might have not mentioned this yet, but we can only cancel out the logs when there's only one of the log on each side. Like this here, at this stage, we couldn't have canceled out the logs and then set everything equal to each other. No, you can only cancel out the logs when there's only one log on each side. And then you could try to cancel out the bases. So based off this, now I have x squared minus 4 over x plus 2 equals 1. Okay, so one way you can solve this problem is to kind of do it what we did before, right? Where the denominator you can get rid of if you multiply it by what it is. So if I multiply this side by x plus 2 to cancel out this bottom, I would have to do it to this side. And I could do that, and it'll get me to the answer, but there's actually an easier way, and I'll show you. So this here is just division, right? You have x squared minus 4 divided by x plus 2. I want us to focus here on the top. This top here is actually a quadratic equation because you have x squared. So I can factor that, or maybe I can. Let's see. I'm going to attempt. I'm going to drop down my x's. Think about what multiplies to give me 4, negative 4. So 2 times 2 gives me 4. Drop down to 2. It's a negative 4, so 1 has to be a negative, 1 has to be a positive. If I multiply these two, I definitely get negative 4. If I add these two, negative 2 plus positive 2 cancel. That's why I don't have a middle term here. So it looks like this factor checks out for this quadratic equation. The bottom is still x plus 2 equals 1. Now you're probably thinking like, Ms. Shang, what are you doing here? Why did we just factor the top? Well, because we're dividing here. And I want to know the factors because, well, it's because we're dividing. Okay, so I keep saying this dividing thing. So I want us to understand what division does. To do that, let's just look at an easy example here. Like 10 divided by 2. 10 divided by 2, we all know, or we should all know, is 5. But let's see what's behind that 10 and why this is the case. So behind the 10 is its factors. So what two numbers make up 10? Well, they are 5 and 2. 5 times 2 gives you 10. If I divide that by 2, what you're actually doing here is you're canceling out the 2's. When there's a 2 in the top, in the numerator, and a 2 in the denominator, they cancel, and so now I'm just left with 5. That's how you get that answer. In division, we cancel out factors. Okay, so I want us to take a look at this problem again. I factored the numerator, and I got x plus 2, and there's an x plus 2 in the denominator. Guess what's going to happen here? They cancel. And so now what I have left is this x minus 2 equals 1. And now, well, this here is super easy, right? Because I got to move this 2 to the other side, so I'm going to add 2. To both sides. That cancels. X is equal to 1 plus 2, 3. Boom. I just got my answer. Oh, wait, hold up. I almost forgot. So this, got to check my answer. So if I plug this 3 into here, 3 squared gives you 9. 9 minus 4 is 5, so that's positive. 3 plus, plugged into this x is 3 plus 2, which is a positive number. That's good. So this is a valid answer. And there we have it. That's one way you can solve this types of log. Now this one here, this problem is not going to be on your current test. The reason why I throw it into the packet is because this is actually a sneak peek. These rational functions here are actually a sneak peek to the next unit that you're going to see after this test. So that's why I brought it here, just to give you a glimpse on what we are going to be doing. Okay, that's it for this journal.